Today we're going to learn how to compare fractions. And we're going to be comparing fractions that don't necessarily have the same denominator. Before we get started with fractions, let's see if you can remember how to compare whole numbers. I have three sets of whole numbers here. I'd like you to mentally draw your greater than or less than symbol. That would look like greater than, less than, I believe that would be less than, greater than actually, and equal to. One of those symbols would fit in each of these pairs of numbers. I would like you to mentally do that. If you need to pause the video, do so. And here come the correct answers. 456 is less than 546. We can tell that because they both have 3 digits in their numbers. They're both in the hundreds place, but the 4 is less than the 5. And the second set of numbers, 3,200, is greater than 3,020. We know that because both of these numbers have 4 digits in them, meaning the first digit is of both numbers fall in the thousands place, but those are exactly the same. They're tied, so we would go to the next number, the 2 and the 0, which is both in the hundreds place, but the 2 is larger than the 0, so at this point we can say that 3,200 is larger than 3,020. And on the third one, we have 99,999 versus 100,000, and of course 100,000 is greater, and we know that because there are 6 digits in 100,000. We only have 5 digits in 99,999, meaning the first digit in 100,000 is worth 100,000. And the first digit over here is only worth 10,000. Well, get ready because now we're going to start looking at some fractions. We're going to be comparing fractions such as 3/5 versus 4/5. Which is greater? I need you to start looking at these fractions and trying to find an easy way to compare them. There's a few tricks you can learn. One of those tricks, the simplest way to compare fractions, is if the denominators are the same. Here we have two fractions where the denominators are the same, and that is going to make this easier. Why? Because if the denominators are the same, then that basically means that the pizzas or the rectangular fraction bars are also the same. They're both the same number of pieces that it takes to make a whole. Each of them takes 5. But in one of these fraction bars, you have only 3. And in the other one, you have 4. And so, when the denominators are the same, or when the number of pieces it takes to make a whole is the same, then we can simply look at how many pieces you have. And whoever has the most pieces wins. Let's take a look at one more of those. Let's try 7/23 versus 18/23. You can pause this video now if you need to and figure out which of these two fractions is the largest and mentally put your sign right there. If you said 18/23 was the biggest, you'd be correct. If you're a pizza lover, then all you have to imagine is that both pizzas are the equal size. They both have 23 pieces in them. But in this fraction, you get more of them. You get 18. Therefore, that's the one you're going to want. That makes 18/23 larger. These types of fractions are easy to compare. Why are they easy to compare? That's right, that's because we're dealing with the same size pizzas. Both pizzas are the same. They both contain 23 pieces, so they're equal in size. The only difference is how much of it you're going to get. It's the numerator that tells you which is bigger here. Let's move on to a different kind of fraction. The kind of fraction that doesn't have the same denominators. But instead, they're going to have the same numerators. Let's take this fraction 2/5 and compare that fraction to 2/7. Which do you think is larger? Pause the video if you need to think about that. Place your imaginary greater than, less than, or equal to sign in that circle. We have a little bit more of a difficult problem here because we're not dealing with the same size pieces. Under this fraction, we'll draw a picture of a whole pizza, but the pieces are cut into 5, 2, 3, 4. But on the other fraction, we're going to draw the same size pizza, but we must cut this into 7 pieces. 1, 2, 3, 4, 5, 6. And since the whole pizza on this fraction is cut into larger pieces than the whole pizza on this fraction. These have to be smaller in order to cut them into more pieces. Now we can take a look at our denominators and maybe we can visualize which is larger based on the fact that we are getting 2 pieces of pizza here and 2 pieces of pizza here. So if we shade in our 2 pieces here, what you're noticing as you shade this in versus shading in 2 pieces over here is that the 2 pieces on 2/5 are larger than the ones from the 2/7. That's because we took the same size pizza and had to cut it into more pieces over here, so they had to become smaller. The more you cut it into, the smaller those pieces get. But regardless, you're still getting only 2 pieces from either pizza. So, if you're a pizza lover, you're going to want the 2 larger pieces, not the smaller ones. So therefore, we can assume and visually see that 2/5 is larger than 2/7 because you're getting 2 pieces that are larger than the 2 pieces you're going to get over here. Of course, we have another way of comparing fractions just to make sure that this is absolutely correct. We have learned already that there is a way to cross multiply, so we can check our work by comparing these fractions in another way by cross multiplying. 5 times 2, which is 10, and 7 times 2, which is 14. And we can see that 14 is larger than 10, and that is just another proof that we are correct. Well, we're not done yet. We still have to figure out how we're going to compare fractions that don't have the same numerator or the same denominator, such as a fraction comparison like this. 3/4 versus 5/8. How are you going to do that? Well, we have a few different options. We already know of one in which we can cross multiply. That's a pretty good option. We're not going to explore that possibility right now. Instead, we're going to explore finding a common denominator. We know how easy it is to compare if the denominators are the same, but they're not. This one's a 4 and this one's an 8. But what if we could convert one of these fractions into another fraction with the same denominator as the one we're comparing it to? And there is a way to do that. In this case, with these 2 fractions, we could ask ourselves, is it possible to change 3/4 into a fraction out of 8? And we've seen this before. So we already know that if we can find our multiplier What are we going to multiply 4 by to get 8? We can do the same thing to the top, and we'll come up with a fraction that's equal to a fraction out of 8s. What is the multiplier here? Hopefully, you said it was 2. 4 times 2 is 8. So then we would do the same to the top. 3 times 2, which is 6. So what we've just done is converted 3/4 into an equal fraction out of 8. And now we can compare. But we're not going to compare 3/4 to 5/8. We're going to change the 3/4 to 6/8 because they're equal. So I'm going to just put that up here. And now we can see that we have two whole pizzas that are cut into the same amount. Both of them cut into 8 pieces. And now it's as simple as understanding that you want the most pieces. So 6 out of 8, you're getting 6 pieces out of 8, is better than 5 out of 8. Therefore, 6/8 or 3/4, they are equal, is greater than 5/8. Let's take a look at another fraction with unlike denominators and unlike numerators. Try 4/5 and 5/7. Again, we're going to use the same method we just used, but we have a different situation and problem here. There is no way to compare 4/5 to a fraction out of 7ths. There's no multiplier that you could use to go from 5 to 7. That's not possible. So we need to find a different way to create or change these fractions so that they have the same denominator. So one way we can do this, or the way that we're going to be using most often, is to place these fractions on top of each other, 4/5 and 5/7. And we're going to change both fractions. Since we can't change one to the other, because there is no multiplier, we're going to change them both into two different fractions with the same denominator. How are we going to do that? We're just going to take a look at our denominators here, and we're going to use our math facts knowledge and multiply 5 times 7. 5 times 7 equals 35. We're going to convert both of these fractions into new fractions with denominators of 35. This should start to look very familiar to you, as now we are set up so that we can simply find our multiplier. What's our multiplier? What do we multiply to 7 to get 35? Well, we actually multiplied 5. You can see we used our two denominators, so this makes it easy to find our multiplier. So we did 7 times 5, that's how we got that. And just like before, whatever we do to the bottom, we do to the top. 5 times 5 is 25. So 5/7 is equal to 25/35. We're going to do the same to the top fraction. Our multiplier here, which is easy to remember because we multiplied these two denominators to get 35. So what did I multiply to 5 to get that? Well, I multiplied this denominator, 7. So this is why it's probably best just to multiply the denominators. 5 times 7 is 35, and we do the same thing to the top. 7 times 4 is 28. Well, we have two new fractions, but we have two new fractions with the same denominator. The pizzas are both the same size and cut into the same exact number of pieces. It's as simple now as looking for the fraction which would give you the most pizza, which would be 28/35. 28/35 is larger than 25/35. Therefore, 4/5 is larger than 5/7. If you need to rewind this and to look at that one more time, please do so now before we move on. Now I would like you to open your Show Me app or some whiteboard app or get a piece of paper and Write down the following 3 math problems and solve them, ready to share with the class when the time comes. The first fraction I'd like you to compare is a fraction with common denominators. 3/8 versus 6/8. The second fraction I'd like you to compare is a fraction with the same numerators. 4/9 and 4/8. The third problem I'd like you to solve is comparing fractions with unlike numerators or denominators. We'll try 2/3 versus 4/5. I do not want you to solve these using cross multiplication. I am very aware that that is the easiest way to do it, and I do want you to do that in almost all other situations. But in this situation, I would like you to use the skills I just taught you. So especially for number 3, I need you to convert both of these fractions into new fractions with common denominators. Please rewind the tape if you need to view how to do that again. Good luck to you.